I'm presenting the core question. You're using scikit-learn's orthogonal matching pursuit, OMP, for sparse regression. You have 100 features, 50 samples, and you want at most 5 features, n_non_zero_cofs equals 5. The algorithm finished in 3 iterations. Let's see which statements are definitely true. This is a great exercise in understanding how OMP works. I'm starting the orthogonal matching pursuit, OMP, algorithm. Think of it like this. We begin with no features selected and a large initial error, representing how far our initial predictions are from the actual data. We're getting ready for the iterative process. In the first step of OMP, I select the feature that best reduces the error. This is like taking the biggest step toward a better prediction, and we add that step to our growing solution. Now the error will be smaller. I'm repeating the process. In this second step, I find the next best feature to improve my model and add it. We are getting closer to minimizing the errors. Remember, the best feature is the one that decreases the error the most. I'm in the third iteration now. I select another feature to improve my model, one that reduces the error as much as possible. I've completed 3 iterations. Now, I check if either the maximum number of features, 5 in this case, is reached or if the error is small enough to stop the process. The algorithm stops when one of these is true, not necessarily both, and not necessarily when the maximum iteration count is reached. We're using the orthogonal matching pursuit algorithm, a method for finding the most important features in a dataset. Think of it like a detective searching for clues. OMP systematically identifies the features that best explain the data. It's an iterative process, meaning it works step by step. I have a dataset with 100 different characteristics, features, and 50 individual observations, samples. Imagine 100 different aspects measured for each of 50 people. OMP will help me find the most influential few. I'm telling OMP to select at most 5 features, that is my limit. It's like saying, find me the 5 most important characteristics, and ignore the rest. This limits the model's complexity. The algorithm completed in just 3 steps. Each step involves selecting a feature and refining the results. It finished early, which can happen if it reaches a satisfactory solution before hitting the feature limit. Based on these details, we'll answer some true, false questions about what must be true from the OMP results. We're using the orthogonal matching pursuit algorithm, a method for finding a sparse solution in regression problems. Think of it as a smart way to select only the most important features from a large dataset. It's like choosing the key ingredients in a recipe to achieve the best result, instead of using everything. Our data has 100 different characteristics, features, and 50 different examples, samples. Think of features as ingredients and samples as different recipes. We use this to build our prediction model. I'm setting a limit of 5 features. This means the algorithm will select at most 5 features to build the model. It's like deciding to use only 5 ingredients in my recipe, even if more are available. The algorithm ran for 3 cycles, iterations, before reaching a stopping criterion. Each iteration adds more to the model, much like when I refine a recipe after multiple cooking attempts. The algorithm might stop before reaching that limit if the model becomes sufficiently accurate. It doesn't guarantee exactly 5 features are selected. It's unlikely to reach 0 error unless the data is perfectly described by the selected features. In reality, there's usually some remaining prediction error. The algorithm might have stopped because of the small error reached during iteration 3, not necessarily the iteration limit. Think of it as a chef deciding the dish tastes sufficiently good before finishing the planned steps. It could have selected multiple features in one iteration and none in another iteration. This statement is not guaranteed. This problem uses the orthogonal matching pursuit algorithm, a method for finding a sparse solution in a linear regression problem. It's like finding the most important ingredients in a recipe while minimizing the number of ingredients. OMP iteratively selects features, ingredients, that best explain the data, the taste of the dish. I'm working with a dataset that has 100 different characteristics, features, and 50 examples, samples, of those characteristics. Imagine 100 different properties of houses and 50 individual houses. I've set a limit of 5 features that the algorithm can use in building its model. It's like telling the algorithm, you can only use up to 5 ingredients from the list. That's n_non_0_cofs . The algorithm completed its work in just 3 steps. Each step involves selecting a feature. After 3 steps, it made its final prediction. I'm testing your understanding with a multiple-choice question based on the algorithm's behavior and parameters. Get ready to show me what you've learned. I'm using OMP, a fancy algorithm that finds the most important features in a dataset to predict something. Think of it like a detective trying to find the most important clues in a case, to solve the mystery. I have a dataset with 100 different characteristics, features, for each of the 50 things I'm studying, samples. Think of it as 50 people, and 100 different facts I know about each person. I want to use those facts to predict something about them. I'm telling the OMP algorithm to only use a maximum of 5 of those 100 features in my predictions. I'm imposing a limit of using at most 5 facts to make a prediction about each person. This makes the prediction simpler and easier to understand. The algorithm found a good enough solution after only checking 3 times. It's like stopping my detective investigation after 3 important clues were found. I don't need to find any more clues. This problem uses the orthogonal matching pursuit algorithm, a method for finding a small set of important features in a dataset. Think of it like trying to explain a complex situation using only a few key facts. OMP iteratively selects the features that best reduce errors in prediction. I'm working with a dataset containing information described by 100 different characteristics, features, and observations from 50 different items or situations, samples. Imagine trying to predict house prices. Each house has 100 features, size, location, age, etc., and I have data on 50 houses. I set a limit on the number of features I'll use in my model to at most 5. This is a key parameter in OMP. It forces the model to find a sparse solution. It makes it pick only a few features to keep it simple. It's like saying, I'm only going to use 5 facts to describe this situation, even if more are available. The algorithm stopped after performing 3 cycles of feature selection. Each iteration involves picking the most helpful feature and updating the model until stopping criteria is met. This is an iterative process. Here's a multiple-choice question to test your understanding of what happened. Let's see how well you understand this process. This statement is potentially wrong. The algorithm might have stopped before reaching the limit of 5 features if the error in the model prediction becomes small enough. This is unlikely. A residual error of 0 means the model perfectly predicts all the data, which is rare in real-world scenarios. OMP aims to minimize this error. This is also not necessarily true. The algorithm may have stopped because the error it was trying to reduce dropped below a threshold. This statement isn't guaranteed to be correct. The algorithm could choose multiple features in one iteration and none in another.